Here's my old girl, 1996 R33 GTR V-Spec. Just fitted a couple of bigger turbos to it and increased the boost to 15 to 16 pounds. I've now noticed a misfire between about 5,000 and 6,000 RPM, particularly in second gear, that didn't show up on the dyno. At this stage I tend to think one or a number of the coil packs are probably faulty. Hopefully with this video I'll be able to show you what I've done to cure the misfire. I've taken the engine cover off, removed the spark plugs, taken the coil igniter pack off as well. Remove the camshaft angle sensor, commonly called the CAS. Remove the plug to the injector resistors, and this will prevent fuel being squirted into the engine while we're testing a bit later. We will need a sheet of solid aluminium. I got a piece about 300 by 600. Also some dielectric silicon compound, very important. I used an AGS brand from an auto shop, Parts 4. I also found some Permatech on the internet as well. What we're looking for is any dielectric silicon grease. Here is the aluminium sheet sitting on top of the engine with the coil igniters bolted via an 8mm bolt. Also attached to the bolt are two earths mounted here. A close-up of the wires. And I've attached the coil loom as well. It's sitting in position. Over here is the CAS. I've got that all plugged in and just sitting on top of the radiator. We need a good earth on this piece of aluminium, so I've used a jumper lead. Notice over here that I've attached one side of the jumper lead to the aluminium sheet, and down here is the earth to the engine and the chassis, and I've connected the other side of the jumper lead to there. We want a good connection on this piece of aluminium. Plug the spark plugs in and connect the wiring loom to the 6 coil packs. It's now ready for testing. Once we turn the ignition on, there are extremely high voltages present. Keep your fingers away from all spark plugs. I've turned the ignition on, and as I turn the CAS, you will hear the sparks jumping across the spark plugs to our aluminium sheet. You might see some jumps happening across the spark plugs. The room's a bit darker here, and you get a better view of the spark jumping between the thread on the spark plug and the aluminium earth sheet. Keep your fingers well away. With the spark plug sitting in this position, there's about a centimetre gap between the spark plug thread and the aluminium sheet. A healthy ignition system should be able to jump a spark across this distance. We've established that we should be able to get a good spark from the spark plug thread to the aluminium sheet, but just have a look at the sparks on plugs 4 and 5. You can see an arc between the bottom of the boot and the chassis rail of the coil holders. All the other plugs 3, 2 and 1 are firing a good healthy spark between the spark plug thread and the aluminium sheet. Following this test, you'd want to be checking the coil boots around plugs 4 and 5. I've used a piece of wooden dowel to increase the spark gap. If you have a look now at the spark on plug 6, 5, 4, 3, 2, you'll notice that they all jump from the boot to the coil frame. Plug number 1 has no spark, which is what I would expect for the 6 plugs. The gap would just be too big to jump. In my opinion, the test results show that plugs 2 to 6 would be misfiring or jumping an arc between the base of the spark plug boot and the coil chassis, whereas spark plug 1 would be what I would tend to expect. Plugs 2 to 6 have a nice loud crack, whereas plug number 1 has just a little quiet tick. These are the coil assemblies, and you'll notice when you pull yours to pieces it's very dusty and dirty, particularly across this section here, and in the videos you'll see the arcs actually jumping from this little coil spring up through to this metal component which is bolted to the engine. The spark's jumping here because basically it's dirty. Could even be a carbon track laid down with the sparks that have been jumping. What we've got to do now is to get some soap and water and a good scrubber and clean all the coil up, and I used an old toothbrush with soap and water and scrubbed the inside and outside of the spark plug boot. Once everything was washed and dried, I covered the assemblies with contact cleaner. Everything has been washed and cleaned and remounted again and is now ready for the next step. The dielectric compound is designed to prevent voltage leakage around high voltage connectors. So what we'll do now is coat all our high voltage connectors with this compound. I've used a silicon dielectric compound and liberally coated around this area here between the coil spring and this bottom bit here on the 3 coils. And then what I'm going to do is to push the boot on like that. I'll do that on all 6. I've just attached each boot to the coil. If you look closely on them, you'll see all that silicon dielectric compound oozing out at the bottom of each of the boot. It's what we want to see. Close-up shows the silicon compound oozing out of the spark plug boots. The silicon compound is something that can be used for all connectors, and it prevents moisture getting in, and also allows, like for a spark plug, easy connection and disconnection of the rubber boot. So in the assembly I've put the silicon compound on all connectors. I went back to testing step 2, increase the spark plug gap, and there was no obvious spark jump between any of the spark plug boots and the coil chassis on any of the 6 cylinders. Before we put the spark plug boots in, I've deliberately put a dab of our silicon material in each one of those as well. At this stage I take the silicon compound, put some on my finger and liberally coat each spark plug. We want to get a good seal there so that we don't get any arcs jumping over the spark plugs. Here we are, all the spark plugs back in and the coil packs mounted in their correct position. I forgot to mention I used a drop of anti-seize on each spark plug as well before I put them in. I noticed on spark plug number 5 there was a lot of dirt and grot down by the spark plug. Looks like it either had some water or a drop of oil in there and had been baked on, so I cleaned that out. And I've been using the silicon compound on all the connectors as well. I find they go on a little bit easier, and where the plug packs go on up here I'm going to put those on as well. Don't forget your earth back down there, and this one will go to the plug pack for the igniters for each of the spark plugs. continue with the reassembly. I used the silicone grease on all the connectors. Helps keep the water and moisture out, and certainly allows them to come on and off easily. I went for a bit of a drive and the engine ran really well, no misfire at all. Hopefully watching this video you'll get some ideas about fixing an engine misfire rather than replacing your 6 coil packs.